Well, it's Friday, and you probably realised we didn't do some videos this week because we didn't have electricity this week because of trees being removed and the electricity board having to take the power off to this property. We're fed by 11,000 volts, and it wasn't safe for them to deal with trees. There is a substation on a pole just outside. So, one or two people have mentioned over the months the Breaker 40, which is a CPT only set, and to me is a total waste of time because it's CPT only. Somebody even asked me, why is there another mic socket on the side? Well, I think that's going to be for selective calling. So I don't know anything about them. I've never seen one of these before in my life, and I know they were popular when CPT happened in 1987. What I have done over the years, a couple of years ago, I bought an empty box. No packing in it, which would have been even better. But I did buy an empty box for a Breaker 40. So I felt that was better than nothing. Tells you it's got some controls on it. So we've got an empty box, but we've got a set with a tiny stub of a power lead. I wonder why people do this, because they've removed the fuse holder. So of course the next thing is they connect it up backwards with a hair grip as a fuse, and then the next thing, of course, the radio's got a lot of damage. Now I had no idea. I was kind of attributing these in my mind to DNT, but anyway, that's not the case, and nobody's been able to tell me. But it says distributed by Kernow on the back, so it's a Kernow Breaker 40. So now we know how to file it, not under B but under K. So we'll see what's inside. It says made in Korea, so chances are it could be made by Maxon. So we're going back to 1987, aren't we, with this? So we've got on-off volume, concentric squelch, and a channel thing there, and a channel 9 switch. And is that a bit of a meter on the front? Yeah, it's got a 4-bar S meter. It probably even has a real RF meter. That won't certainly do. We'll get the bigger screwdriver to it. Put the soldering iron on ready. I can't say I have seen the board before, but then I've seen very few CPT sets. I'm going to go to the trouble of taking the bottom lid off because I want to look for board identification. It certainly isn't Maxon built. It's a bit more thrown together than they would do. Yeah, I mean, it's although it is flow soldered to some degree, it looks like there's a lot of hand soldering as well, which, yeah. So if I needed to do any repair work to that, it would have to be defluxed. All the board says on the bottom is 15A. I wouldn't expect it's ever had any repairs, even though there's a lot of soldering around the output transistor there, because I think by the time these kind of things would have gone wrong, you'd have, I think that the 1994 would have happened and the 80 channel sets would have become available. Or people will have discovered, like we do, that 80 channel that CPT just doesn't work because of the interference. What is interesting is a single-sided printed circuit board, but I've never seen this before. It's double-sided in the PA section. So you've got ground plane type construction. I've never seen that. So it's like they've had to etch the entire second side of the board just for that ground plane. Okay, well, synthesizer chip on this. Can I see it? I have to get the angle of the light about there. Oh, it's an LC7131. Interesting. It's been a bit bashed in at the back. So I wonder if on our sheet, and thanks Quotages for sending me the newer one, which still needs printing off. Have we got? Well, they've got Breaker 40 down by just calling it Breaker 40, but I'm going to be calling it Kernow Breaker 40 because it says so on the back. So they've got that down for diagram 1, which is the standard Cybernet type connection, and we have a standard Cybernet connection mic ready made up. The other thing which I'm going to have to do, I've got to do something about this power lead. Because the radio is worthless, I don't want to even spend time and money putting it through that grommet. So what we'll try and do is to put a fuse holder there and extend the lead. So I wouldn't do that for a customer, but seeing as this is our set and it'll just simply go back on the shelf when this demonstration's over, I'm going to have to cut that down because it's tarnished. I'll cut that one down because that's tarnished, and we'll pause the video while I do that. Right, we'll go back into record, and we should now have, if I switch the power supply on, we should have power. There we are. 21, like my age. I feel like my tango number anyway. Okay. We'll connect it to the test instruments. We'll certainly connect it to the test set to do transmit. So switch picture in picture on, and hopefully you've got a view of the power meter. I can't see the monitor because it's LCD these days, and when there was a CRT one in exactly the same place I could see it, but there you are, it's progress. So we will go into transmit. What's it going to be? 2.5 watts? I never seem to get 4 watts out of CPT sets. Whoa! It's just gone beyond the 3. I'm impressed. It is doing about 3.1. Well, what we're going to have there then? Well, it's going to be guess the preset time. Don't think I'm going to have to do a chart on this, but I would suspect that all we've got for transmit is going to be there and there. So we're going to have the VCO there. I don't know, they could be on the transmit side. It doesn't matter if I mess them up because obviously I can put it back right with the test equipment that's here. We'll give it a go. Yes, it is. Transmit. Transmit, that's improved matters. That's the yellow tool on the floor. So there we are, we've got 3.5 for what that's worth. I would think that the preset there is going to be the RF output meter. So let's see what happens. I'm going to transmit. I've got 4 bars. Well, I'm wrong there. Wonder what that does then. I've hunted high and low to see if I can find a circuit diagram, but to no avail. In fact, I can only see 2 other presets, and that's there and there. And you would expect them to be in the receiver. That couldn't possibly be deviation, could it? Let's get the little oscillator out and see. Now I'm going to have to retune the test equipment because it's CEPT, isn't it? So it's 27205. And normally we're on UK channels, so it's lower. No, it's not in tune. Now it is. Oh, I still don't know what that is. No. Oh, I'm going to have to hunt a bit closer and see if we can find a deviation adjustment. Aha, yes. We've got a preset down there amongst the wiring. Let's give that one a go. Wallow, because at the moment it's at 1.4 kilohertz, which is doing the wrong one. Is that one? Yeah. Wallow. Well, I've turned it up to full and we've got 2. Wallow. Just manages 2. That's a bit too low. I mean, I don't do modifications, but it needs to be more than that. But it'll do. It'll do for the demonstration. I mean, this must have been miserably quiet. Hello, can you hear me? No, are you the whisperer? Roger, I'm the whisperer. Well, so I'm still at a bit of a quandary why I've got a preset there which isn't affecting the meter, because it's right smack bang in the middle of the transmitter. It's not like the radio's got low power, so we'll have to come back to that. I don't know what's happening there. And looking at the printed circuit board on the bottom, it's configured as a rheostat. It's only got 2 legs connected. So let's see how on frequency it is. So if I move the camera across to that, we should have 27205. 20449. Well, it will have dropped with age, which is what happens. So is it adjustable? Because not all sets are. So it's in spec, but it's just a bit lower than I would hope for. No, it doesn't have... Oh, it does. It's under that capacitor. Wow. So I want it to go up, so I'll turn it to the left. That's usually the way it works. Except today. Turn it to the right for it to go up. There we go, 27205 and a little bit, that's fine. That's another task done. So we'll have a look at the receive, and we'll start by putting the test equipment onto the oscilloscope. And we'll look at the detector. So once again, I'm going to have to set the test equipment for 27205. It's normally not there because it's normally channel 20 on UK channels. The reason I'm pushing this through is there was some interest for some bizarre reason, and at the moment we did one a week ago, CEPT set a week ago, and it wasn't the usual dreadful foreign interference, so it actually worked for once. I thought, well, we'll take the opportunity to do another one. There we go. So now if I plug in my extension speaker, we should have something. We have. So the detector is the first thing I'm going to be looking for, and I would expect it to be that coil there. So we're looking for maximum amplitude on that oscilloscope. Okay, well that was an improvement, so that would have been a bit quiet and distorted as it had been. I hope I didn't pay much for this set, because it'll only be worth a £5 when it's done. Probably paid more for that box shell. Right, let's see what's on that meter. Now, of course, I've messed all these up, haven't I? It says 2. Well, I would think we want 3 lights lighting, and it's going to be one of those 2 for that meter. And it's that one. So, full chat is 3 lights, and going up with the signal generator we can get 4. So that's, we'll call that S9. So I think we're about right there. So that's another thing done. So it's the lower preset. We had deviation under the wiring. We've got S meter there. That's going to be squelch when we get to it. But let's see how sensitive it is. Apart from sounding pretty awful. So I'll move the camera onto the cyanide meter, which happens to be just there. And we'll set the signal generator. In fact, it's so awful, it makes me wonder whether some of the IF cores have been tampered with. So I will just see if I can touch those up a bit. Yep. That was out. Perhaps some screwdriver expert thought these did the transmit and they wanted a bit more than 2.5 watts out of it. Right, now we'll look at the cyanide. We'll do the front end coils. Wow, that's made an improvement. I'm going to go back to S9 and I'm just going to check that the detector's still correct, because of it could be interactive with all those IF coils that have been messed up. And we'll go back to the IF coils now. Just see whether I can just improve that. Yeah, that's about where it should be. I wouldn't say it sounds normal, but we'll see what that's like on the air. We'll get a cyanide reading. So let's see if we can get 20, and this is always subject to how noisy the transistors are. We can. And it actually, amazingly, it's 0.75 microvolts. Wow. About 12. .29 microvolts, and for 10 decibel cyanide, .25 microvolts. So sensitivity looks alright now, but you could see how they were so messed up. So let's have a look at the squelch. I'll turn it to full. Now, of course, I've messed up with that preset, and that's going to be the squelch. So we'll turn the signal generator to... In fact, I'll move the camera so you can see the attenuator controls, so you know I'm not lying to you. So at the moment we're at 10 microvolts. I've got the squelch at full. I want it to be 100 microvolts when the squelch opens, but it's coming in at 30. So I'll just back that off. It's going to be the preset there. Is it? Well, it isn't going to be the preset there, is it? How can that be? It is squelch. Now the strongest still set to is there. So to give you some true reading, the maximum squelch I can get is 15 microvolts. I'd like it to be 100. So it's a bit wishy-washy, that, especially on a band which is usually S9 of rubbish. So let's see how it works at the other end, at the sensitive end. So I'll now park the signal generator at 0.3 microvolts, switch it off, turn the squelch down to minimum and set threshold. Switch the signal generator on, and let's see when it comes in. Now we're going to have to back off that top end, this preset. That's too strong. So reset the threshold. Switch the signal generator on. I'm going to have to back it off further, it's still not sensitive enough. Switch the signal generator off, reset. So now we've got it I can't get it better than 3 microvolts. That's really insensitive. And of course now at the top end, the maximum it's going to squelch out is what? 30, we're looking at, yeah, 30 microvolts is the top end. Well, that's the best compromise I can come up with. So it's a bit of an insensitive squelch, and then at the top end it's a bit of a weak squelch. So that's squelch. So once again, deviation, S meter, squelch. That has to be RF meter. So let's go back to transmit. I can lose that. So I'm getting a full set of bars. I'm actually going to turn the power supply down just to get myself less power output. So I'm going to turn the power supply down until what? I'm now getting 2.5 watts on the power supply with the power supply turned down, and I'm still getting 4 bars on the radio. So let's see whether I can adjust this now. Yes, I can. So that really is, as I thought, the preset for the power output meter. So we'll set the power supply back. We see that little technique to find out, just to prove once and for all. But we need to just prove now that we're going back to 13.8. So let's see what I turned it down to, because there are analog meters on this power supply, and I turned it down to 10.3 to do that. So we'll go back to 13.8. That'll do. And now we'll be getting a full set of bars, but we do know they did adjust. And just for the record, it is transmitting at about 3.5 watts. So there we have it. Right, so we put it back together and let's see what happens. "19 a Roger." Well, that's not going to happen. Well, that was pretty uneventful. There's nothing out there, so it's nice and blank. So our little on-the-air test later on will no doubt be quite okay. So I've never seen one of these before, but we found our way around it. And 4 watts, rubbish squelch. Apart from that, it seems to work all right. So the proof of the pudding will be in the eating, as they say. And we'll do an on-the-air test later on. And let's hope YouTube don't transmit it twice. I had to manually edit that last video when they went and repeated it. I don't know what they do apart from lower the quality. Thank you for watching the Kernow Breaker 40, and if any of you got a circuit diagram, give me a nod, because I would love to see and prove that that is the cell core socket. Thank you.